Welcome back, everybody, to our live streams from Devoxx Belgium. I'm a little bit under the weather right now. I had a lot of coughing during my talk earlier, by the way. Not just from me, I'm saying from the entire audience. Not sure whether you heard that too.
A bit.
It's a bit like it's October. Okay, so I'm here with Stefan Johansson, who confused me with his last name intentionally, or his parents probably did this. Right, but anyway, so Stefan, for those of you who don't know you, why don't you introduce yourself and then also maybe explain why I'm being continuously confused?
Yeah, so thanks. My name is Stefan Johansson. I work in the GC team at Oracle in Stockholm, and the thing that is confusing, Nicolai, is that we also have a Stefan Karlsson in the GC team in Stockholm working on the same project. So he's not the only one confusing us, but we're doing more or less the same thing.
Okay, yeah, I'm very sorry about that.
And it's no problem. You're not the first one. And it's kind of fun.
At least I got that working for me. You just gave a talk a little earlier today about garbage collection, and it was kind of like a broad strokes talk, right? It wasn't like just this one thing.
No.
So why don't you give us like a tour de force through the talk?
So basically, I had two main goals with the presentation, both giving like the viewer an introduction to GC, making them understand why it's important to understand it a bit, and also understanding what's the most important thing for your application so that they can choose the correct GC. And then the second part was more about performance and all the gains that we've seen since JDK 8, like for over the 10 past years, all the development we've done, what that have done to performance in GC and in Java in general, because this is a big part of Java performance.
So it immediately opens up two avenues, right? The one is, yes, there's new garbage collectors being developed, GGC, Generation GGC, we can talk about that. But then you're saying it's not just that. Not better performance does not just come from picking a different or more modern garbage collector, although I'm not sure that term really applies more modern, but just does not come just from that. It also comes from just keeping the right garbage collector for you and seeing it improve through JDK.
Yeah, exactly. So we usually talk about three different things, like when you care about performance, or three main things, like throughput, latency, or footprints. So depending on what your application cares most about, is it something that just want to process a lot of data?
Yeah, exactly. Sorry, I was going to interrupt you. Can you quickly explain those three? But I think
okay. So with throughput, roughly we talk about the raw number of transactions that you can complete in a set amount of time. Latency is more of like the time it takes to complete a single transaction, or the worst time. So if you have a GC pause affecting a single transaction, that will affect the worst case latencies. So that's from the latency point of view. And then footprint is the overhead that you see from the GC algorithm in terms of additional native memory used or additional CPU resources used. So you need to figure out what's most important for your application. So for example, if you have a very small cloud service, like additional overhead might be the worst thing for you, because you don't really care about throughput or latency because you never really experience those things if you have something like a function as a service or something like that. On the other hand, if you have a UI application, you probably care about the latencies because you don't want your user to experience long lags when you have a GC pause and things like that. So you need to understand what's most important for your application when you're choosing the GC algorithm to use.
Okay, so can you give us you gave us a few examples, but are there like more general guidelines that you can give the audience when to pick what? I mean, nowadays, I don't know any numbers, I don't know any percentages, but I would guess more than half at least of the Java applications are probably backend services.
Yeah, sure.
So what do you think?
Yeah, I mean, for backend services, large backend services, I would, in most cases, look at G1 and CGC. There are multiple reasons for this. Those are the two garbage collectors that we spend most of the resources in, so those are the one that's probably continuously getting better, mostly, because we spend most resources on them. They are both focused on latency and somewhat throughput, especially G1 is trying to get this balance between latency and footprint.
Which is probably why it's the default.
Yeah,
because it tries to sit in the middle here.
Exactly. That's why we changed the default from Parallel since JDK 9. Because Parallel has this problem with sometimes when the old generation, like when the heap fills up and you need to collect the whole heap, you get those worst case latencies because you have to collect the whole heap at a single GC. And G1 is able to avoid this by doing something called mixed collections. And I don't want to go into the details about that here, but if you watch my talk, I go into this a bit deeper.
So that talk will be, as the other ones that we all mentioned, on the Devoxx YouTube channel probably soon, and then on the Java YouTube channel in the coming weeks. Subscribe to either or check out either, both are fine. And then, it makes sense probably to go to more detail there because we're struggling, like we have just our hands to explain, and probably a slide, some arrows, some boxes with colors, and will probably help.
It helps a bit.
Okay. So, but still, Parlog GC though, I want to come back to that because it's still, like, my understanding is, and correct me if I'm wrong, it's still the best thing I can use for something like a nightly batch job or something where I really don't care about latency. All I care about is getting the maximum throughput with the minimum.
Yeah.
Okay, is that also still true regardless of heap size? Because I hear like GCC is like very, very large heaps, so if I have like terabyte size heaps, is Parlog GC still doing a great job there, or is that...
Yeah, I mean, it depends. And you should always, I say this a lot of the time, you should always try at least two of the GCs. You should never ask, okay, so I have a batch processing workload, I should go with parallel. You should always evaluate at least two. And in this case, if you grow the heap size, I think CGC can actually be an alternative as well. But I think, like, the first thing, if you grow the heap size extremely large, you still want good throughput, I would certainly look at G1 compared to Parallel.
Okay.
Parallel is still very good when it comes to throughput because it has cheaper write barriers compared to G1 if we're going to go low level. But this is also something that we're looking at going forward in JDK 24 and 25, are looking into trying to make the G1 barriers cheaper. So going forward, it might be even more compelling to look at G1 when it comes to throughput performance.
But that also means that this is a moving target, that people cannot just pick one and then let
no,
it
you
run
should
for the
always
next decade.
reevaluate. I mean, we've heard so many people over the years like, we tried out G1 in JDK8 and it didn't work for us, so we're not going to use that one. And like the progress that we've made with G1 since JDK8 is exceptional. I mean, the improvements that we've seen across the board. I mean, the pause times in the benchmarks that I show in the presentation, we're down from 120 milliseconds down to 60.
Is that like average or worse?
That's the P99 pause times.
Oh, wow. Okay.
For a 16 gigabyte heap using G1 in a benchmark. So, I mean, benchmarks is benchmarks. But still, we cut the pause in half. We improved the throughput score with, I think, something around 40% between 8 and 17.
Okay.
The latency score is doubled between 8 and 17. And
that's good if the latency score is doubled.
Yeah,
it's
exactly.
not the latency that
no.
Okay.
So that's a fun thing with this benchmark. It's called SpecABV 2015. It has a latency score which is basically throughput with latency constraints. Okay. So that's why the score. That's why higher is better when it comes to latency there, because you want to be able to push the throughput but still keep the latency, keep the SLAs.
And that's also kind of a realistic use case, right? You have for your backend, you have a certain amount of latency that is in the P99 that is acceptable. Yeah. And then you want to push the app to get as close as possible, to get as much out of while still fulfilling that requirement.
Yeah, exactly.
Okay, so we talked a little bit about the different garbage collection and a little bit when to pick which. Yeah. One more thing that's probably important here is that people do have a way to measure that, right? Because we say it is a moving target, different Java versions do increase, and then also, if I understand you correctly, it also means, well, Parallog GC or G1 or GCC might be the best choice now on Java 21 or 23. It could be different in a couple of versions. So that means, because they see uneven improvements.
Sure.
So it would be really helpful if people had a good way to measure that, which is a big own challenge that we're probably not going to get into. No. But it's really hard to have a measurement. I mean, batch jobs are kind of nice here. It started at end time, and you measure CPU
it's quite easy.
But everything else, I know it's hard to put a realistic load on an app that is not artificial in a certain way, that has certain allocation patterns that do not reflect real-world use case.
Yeah, I mean, this isn't like something that you can go and rely on totally, but I'm trying to release like a comparison similar to the one I had in this presentation for every long-term support release that Oracle does, like 17, 21, I've released like this. I
appreciate your wording so much. Every long-term support that Oracle does. Good. Okay, sorry for the interruption.
But trying to show like the progress using this benchmark in those three categories, like latency, footprint, and throughput. So that you can see that, like, for example, right now, between 21 and 23, we've done footprint reductions in Parallog GC that didn't show up in my slides here, but will show up into 25, making Parallel the most memory efficient of the like high performance collectors once again, because G1
so much improvement.
G1 saw so much improvement within 8 and 21 that G1 is currently in 21 the most memory efficient collector on that benchmark.
That is so surprising. I didn't know that. I mean, I've just very recently told people wrong information then.
Yeah, I mean, in JDK8 in this benchmark, the additional memory overhead for a 16 gigabyte heap is 2 gigabyte of native memory in JDK8. In JDK 21, we're down below 750 megabytes.
Okay.
So that's a pretty good improvement. It's 10 years, but it's so good, really great improvement. And Parallel, I think, is around 800 or 900 megabytes, but in 23, that's down to around 700 also. Okay. So it's we're having some internal competition there.
I was going to say that's different teams, right?
Yeah, no, it's not really. We have a CGC and a G1 team within Oracle. It's not bulletproof. Like I'm trying to stay like in both, because I worked on both. I worked on G1 for a long time. Now I'm focusing more on CGC, but I can't really let G1 go. So try to stay involved there as well. Parallel is more like we have one guy working pretty much on that, then we all of us help out whenever we need to do work, but we're not focusing as much on Parallel as we do on G1 and CGC.
Because of the reason we discussed, right? It's the one that's probably, first of all, it's already doing a pretty good job, but it's also not the one that is in most demand right now. Maybe it's also not the one that is the most improvement to be made. Right? If you can invest 10 years and cut basically into a third the overhead, and you spend as much time in parallel GC to get another 50 megabyte out.
And there are like design decisions in serial and parallel, like the way that we did things back then, like with how the generations are sized, how the heap layout looks. Both G1 and CGC are region-based when it comes to the heap layout, which gives us much more flexibility in how we garbage collect the heap, while for parallel and serial, we have a young generation which is sized upon startup and an old generation that is sized upon startup. So it's not as flexible. So you can't do as much tricks. Okay. So that's why more of the development is going on. And that's even more
room for improvement.
Yeah, and that's even more true when it comes to CGC is the newest addition to the garbage collector family, and it makes use of colored pointers. And this is another thing, G1 doesn't have that. But the color pointers give us opportunities to do other features that's going to be probably harder to do with G1, but we're going to be able to do some really cool stuff, hopefully going forward with CGC because of this new thing with color pointers. So, depending on design choices, the different collectors allow for different features going forward. So.
So I have a question about generation GGC. I also had a question basically just popped up about Parallel GC, but I have all these questions as well. I want to ask that one first. I wanted to ask what is, in your opinion, the best choice for an application running inside Kubernetes, and the amount of CPUs available to the container is 2. So the app runs in a Kubernetes cluster and has 2 CPUs available to it. What do you think would be a promising garbage collection choice?
Super hard to answer without knowing exactly what the application is doing. But this is typically one of the cases where you have a pretty small container. It could be, depending on what the application is doing, that serial is actually a really good alternative there. Because serial will, depending on the heap size. Did you say anything?
No, heap size is not specified.
No. So depending on the heap size, the problem with serial, if you have a large heap, serial uses only a single thread to do the GC work. So if the heap is large, serial is probably not a good choice. G1 could be a good alternative here, doing most of the work in stopped world collection in pauses. And now if they are on JDK 21, G1 is pretty memory efficient, as I mentioned. Not as memory efficient as serial is, but this is always the case. If you have small services running in small containers, maybe serial is a really good choice because the overhead added by serial is so low. So
it's even less than parallel.
It's even less than parallel.
So it's basically just like the garbage collection algorithm, just doing its thing.
More or less. We have some side structure, but with parallel, we have marking bitmaps to keep track of liveness information. In serial, this is kept within the heap. So this is additional data structures that we don't have to allocate with serial, which makes the memory overhead lower. So there are.
So maybe we get more information from for the question. There's a pretty long round trip time between the video and the chat, but eventually if I see it, we'll maybe get back to that point.
But that's usually always the case. It's very hard to just give a raw guide. But
if we don't know the heap size, we don't know what the application requirements are, so that's what we'd be guessing. So one thing that I want to ask about what you just said. You said that more like newer garbage collectors, G1 and then GGC being the newest one, have presumably more advanced mechanisms that allow, as you said, for greater flexibility. You mentioned regions and color points. Okay, so let's say, I don't know, some company says, look, I got these 10 performance experts, they're really bored, I don't know what to do with them. Use them. And you want to use them to make like the best Parallel GC replacement. Like you want to, right? So get one that is really just, I don't care about pulse times. All I care about is minimum overhead and maximum throughput. Do you think there's like with, for example, I'm not sure whether that applies here, regions and color pointers and other methodologies. Do you think like a from scratch Parallel GC replacement would be a big leg up from what Parallel GC is right now? I mean, I know it's a crazy hypothetical.
It's very hard to guess upon, but I don't think. I mean, the way the Parallel is implemented, like the way the barriers work there, it's pretty optimal. So I'm not sure that we're going to see a lot there.
Okay.
As I mentioned.
Because you mentioned the flexibility that regions give you.
Yeah, exactly.
And like Parallel benefit from that.
Exactly, but that's what we're doing in G1 right now. So right now in G1, we're experimenting, trying to improve the right barriers of G1 to be more similar to the ones in Parallel. So hopefully, going forward, we can reduce some of the overhead that the G1 barriers have inflicted in the past and get better throughput with G1. And then having the region-based and having the concurrent marking in G1 to be able to avoid those worst-case latencies. I think G1 will be a better alternative. Maybe not because it has better throughput, but it might be as close and you have the other advantages of G1. But yeah, I'm speculating a bit. We don't have the exact numbers now, but it looks promising. And finally, I mean, we've spoken about this for, I think, the last 5 years that we want to look at the G1 barriers, but we've never had time. Now we've got help from a compiler engineer doing some of the groundwork, taking a prototype from one of my colleagues that also borrowing ideas from CGC. And this is something that's really great, like the synergy effects between the different GCs, like things that were implemented in CGC that we in G1 then can later make use of. It's really great to see.
Although I would argue that just from an organizational standpoint, it's all the more important that these GCs have separate targets, separate goals to work toward, because you don't want to end up with G1 getting, moving into the GGC space and losing its advantages that it had.
Totally agree.
We talked about GGC a bit. 23 G1 remains the default garbage collector. So I just have to say that up front because I'm now going to talk about different default. G1 remains the default garbage collector. But if you use GGC, now for the first time in 23, generational GGC is the default.
Yes.
The generational mode.
Exactly.
As a little bit of a closer, maybe you can talk a little bit about that, about what's going on with that and what your ideas are for the future for that.
Yeah, sure. So first off, I guess we should explain what generational is for the viewers. So generational CGC, generational collections is a feature that is very important from a performance point and making a collector suitable for more use cases. So basically what we do is that we divide the Java heap into a young and old generation, and then we place newly allocated objects in the young generation, and objects that are long-lived and kept around for a set of GC cycles are promoted to the old generation. With the idea that those seem to be long-lived, so we don't need to garbage collect those as often.
So that's the generational hypothesis, right?
Exactly.
That young objects usually die young.
Exactly.
And once they pass a certain threshold, they're probably going to be around for a long time.
Exactly.
And you can see this in the web app, right? You have certain objects that you need for the entire web app. Exactly. Runtime, and then there's like a new request comes in. Let's parse some JSON. Let's create some strings. Let's create a user object.
Exactly. So those objects will end up in the young generation, and when we do collect the young generation, most of the objects are dead. We don't need to copy them anywhere, so there's not a lot of work to do, and we can free up a lot of memory very cheaply. So that's the idea around that. So for CGC, that was implemented in JDK 21. But in 23, this is the mode of CGC that's on by default. So that's a great progress for us. We really want people to use the generational mode. Because going forward, we will remove the single generational CGC. So the old one, the mode of CGC that was around in JDK 17 is not going to be supported anymore after, I'm not sure which version, but going forward. So people should really try to move over to the generational mode, either by, in JDK 21, specify the flag C generational, or by using JDK 23 and try it out. And if they have feedback, we're super happy to hear about that. But most of the time, we see really great improvements by using the generational mode.
So if you're interested in that, Netflix wrote a blog post about that. What is that, Gen ZGC, bent pause time, you will or something?
Exactly.
So that's a great article. So do look at that if you're interested. Also, one reason I think why the old mode was going away, if I understood correctly from the mailing list, Gen ZGC is not just like, we made a few changes and there's a switch to flip. It's like a big chunk of the code base now, right? And so it's a lot of maintenance work to keep both modes alive.
We actually, I mean, from our point of view, we never intend, or we didn't plan to keep both around at first. So we rewrote what needed to be rewritten in CGC to be generational. So it was a really big feature to write and to change out. So to be able to have both of them, we basically have duplicated code bases.
Oh wow!
So it's
so you basically, it's not like you have like one big core and then there's like two things on top. You're basically saying, no, it's basically the old and the new. Okay.
Yeah.
Does it also mean, by the way, you said people can already try on 21, and we're going back to what we said earlier, let's say they tried and it's not quite up to snuff, will they see something better numbers in 22 or 23? Has that also been improved?
It's not that big of a difference between 21 and 23. So the generational mode in 21 is still as good as the one in 23. We've done some small improvements, but between 21 and 23, big parts of the team have been focusing on other things in the code base to clean up and enable future improvements. So we have a lot of ideas for CGC going forward, but between 21 and 23, not a lot has happened. Okay. And that's the same for single generational CGC between 17 and 21. Between those,
because you were
we were only working on the generational mode of CGC.
Okay.
So between 17 and 21, you won't see much difference of when it comes to CGC. Then, of course, the rest of the Java platform have improved. So you can still see. No, it's not just garbage collection. You need to make sure.
So we got to think about detail on the other question. And so at this point in time, talks are over. More people are coming, so it's getting a little bit noisier. We will cut this probably short at some point. But let's see as long as we have time. We got details on the other one. So configuration. So continuation of the Kubernetes. The app running within Kubernetes cluster CPUs available now too. The configuration is using a limit clause in Kubernetes to 2,000 MB bytes, I guess, or 2 gigs. Since I read that Java Economics will always choose 0GC when one CPU is available, I put 2 CPUs. Plus, now we're getting to serious performance requirements performance engineering over YouTube comments. Anyway, so we put 2 CPUs and max RAM percentage 75 and use Parlog GC. So that's the current configuration. Okay. So 2 gigs, 2 CPUs.
2 gigs, 2 CPUs. I suppose he saw some problems with serial because he didn't want that. That's why he added a second CPU. I would certainly, depending on what your version is on, I would certainly try out G1 as well. Compare it against Parallel. It's very hard to say which one of those will be working the best. It's also dependent on what his requirements are, but I would certainly try both out.
Okay. As a closing question. And it's stated as a just out of curiosity, or mainly out of curiosity question. Is there a significant, in parentheses, is there a significant use case for DGC in low memory workloads?
I mean, it's.
So does it work like so?
It does. In my slides, I say that CGC is suitable above 4 gigabytes, but I also add the disclaimer that it can handle much smaller heaps, because we've done some internal testing where it works very well on small heaps. It all depends on how much are you allocating, and how many threads are you allowing to do the garbage collection work and things like that. So but it's like this. The lower you go with the heap size, the more probable it is that G1 might be a better alternative. And the same goes on the other way. Like G1 can handle heaps up to many gigabytes, like over 100 gigabytes. We've done testing and it's okay. But once you go over 32 gigabytes, it's very likely that CGC will be a better alternative for you. So it's So just to clarify, the question is not correctness. It will work correctly. The question is is the resource usage what you would want and expect? Okay. So they have different ranges where they work optimally. Usage-wise, I mean, CGC is never gonna do wrong, but it might run into what we call allocation stalls, or what's called allocation stalls. And that's when CGC can't free up memory fast enough to satisfy the allocations done by the application.
And then eventually you end up with real pause.
That's basically pausing a single thread, the thread doing allocations, but eventually that will stop all the threads if you can't free up memory.
Okay, Stefan, that was super enlightening. Thank you very much. I'm more like a language and API kind of guy because everybody can understand that, whereas the GC internals are something you actually have to be smart, understand things deeply, which is not my forte. So I thank you very much for all this insight. And tomorrow morning at 10, we're gonna talk to Parag Minborg about performance in Java more general. So GC is one big part of that, but he had a talk here where we went over a bunch of different performance improvements. And so we're going to talk about that a little. And once again, Stefan, thank you for being here.
Thanks.
Have a good time at the conference for the last day tomorrow. And I want to tell you to see you tomorrow at 10. I mean, that's Central European Summertime at 8 UTC. See you, bye.